Figures 1112 through 1114 case study a date class. In this example, we're going to take a look at our own date class, and the key part of this example is to demonstrate several overloaded operators, prefix and postfix increment operators, as well as a plus equals operator where the right-hand operand is not an object of the same class. In this case, we'll allow you to add an integer to a date, and what will happen is it will add the appropriate number of days to the current date. Now, in our date class, we have three private pieces of data, month, day, and year. We also have a static constant integer array called days, where we'll store the number of days in each month. And as you know, the number of days in each month never changes, with the exception of February having 29 days in a leap year. So we'll have a separate test for that. In fact, you can see we have a leap year function that returns a bool. We also have this help increment utility function, which is going to be used by several of our other member functions to help us add one to a date. In the public interface, we have our constructor, which has three defaulted arguments, so it's also the default constructor, a setDate member function to change the date, leap year to test for leap year, and end of month to test for the end of a month. And then we have our three overloaded operator functions that we'll be demonstrating in this example. We have a prefix increment operator, which is this first one. We have a postfix increment operator, which is the second one, and we'll talk about the differences between those in a moment. And then we have the plus equals operator to add an integer to the date. Now, before we look at the implementations of these member functions, let's take a look at the running program and the source code for main so that we can see how it works. So here's main, and we're creating three date objects, one that is a default date, one with an actual valid date, and one that takes three invalid values. And if I stop there, actually let's look at line 15 first, where we output all of those dates using the overloaded output operator that we've provided for the class. And you can see here the D1 through D3 date values, where the first and third have the default value, and again we've provided all bad data for the third one, so it set it back to the defaults. And of course, December 27th, 1992 was a valid date for the other date object. Next, we demonstrate the plus equals operator, so we're adding an integer to a date, and we could also have a separate operator that adds a date to a date if we wanted to. In this case, we chose to just demonstrate integers, and a key thing here is that when we did the plus equals operator for class string, the right-hand operand was another string. Here we are using a completely different data type to add to a date object, so it's not a requirement that a binary operator use two operands of the exact same type. And that actually is interesting because you may recall in the string class presentation that there's lots of subtle overheads that can be introduced into a program via conversion constructors and overloaded operators where implicit conversions start happening. So for example, we had the plus equals operator in class string where we added two string objects together, but we also demonstrated that because of the way we implemented class string, it was possible to call the plus equals operator with a right-hand operand, which was a C-style pointer-based string. And that resulted in a temporary object being created, that temporary object getting its contents concatenated, and then that temporary object being destroyed. Well, if you want to avoid overheads like that, sometimes it's useful to provide multiple versions of a given overloaded operator where the right-hand operand is one of several different types. So I might have a plus equals operator for a string on the right side. I might have a plus equals operator for a C-style pointer-based string on the right side as well, and that way I can eliminate some of the extra overhead that was generated in my string class example. So adding 7 to the date, if you take a look here, you can see D2, which was December 27th. We add 7 to it, and that becomes January 3rd, 1993, 7 days later. And by the way, that demonstrates that not only were we able to determine when the end of the month was and move to the next month, we were also able to determine the end of the year and move to the next year as well. Next, we set the date to February 28th, 1992, which is a leap year, and then we add 1 to that date. So we output the original date and add 1 to it to demonstrate that indeed we're able to test for leap year. And then finally, we set up another date object and we demonstrate the pre and post increment operators. Now, you know that when you use a pre increment, the value of the variable changes immediately and the new value is used in the continuing expression. So if I have July 13th, 2002 and I add 1 to it here, it's going to become July 14th, and July 14th will be output in line 26. On the other hand, when you have a post increment, it says use the current value, then increment the variable. So when I do line 31, D4, which will now be July 14th, will be output. Then I will increment it to make it the 15th, and I won't see the 15th until this last line of the output. So if you take a look at the testing part for the plus plus operator, we show you the initial value of D4. We add 1 with pre-increment, showing you that when we finish, the value is July 14th, and then for good measure, we output D4 one more time to show you that the increment happened in the previous statement. In the post-increment version, we output the current date, which is now the 14th. Then we say to post-increment it, so we still output the 14th in that statement. And then to show you that the increment still happened, we output the date object once again. So we need to account for the uses of the plus plus operator in C++, where it can be both a pre-increment and a post-increment version. So let's now take a look at the implementations of our date member functions and overloaded operator as well. Remember, we have a static constant integer array called days that was declared in our class. Here we're allocating that array and initializing it, and we're going to ignore element 0 here and simply work with elements 1 through 12, which also happen to correspond to the month numbers for January through December. Our date constructor just calls setDate to set the date. Our setDate function checks the month to make sure it's a number from 1 to 12, and if not, sets it to 1. Here's a case where we might want to use exception handling instead. Line 20 sets the year, checking to make sure it's a reasonable value from between 1900 and 2100, and if not, sets it to 1900. And then we have a little if-else statement which says if it's February and it's a leap year, whatever the current year value is a leap year, then we're going to check the day value to see if it's between 1 and 29, and if so, use it, otherwise set it to 1. And for all other cases, we're going to check the day value to see if it's between 1 and the number of days in that particular month. If so, we'll use it, otherwise we will set it to 1. So all of these validity checks are checking the value, and if it's out of range, setting the value to a default value. Again, there's a couple of different ways we could consider handling that scenario. One would be not to modify the month, year, or day at all if it's an invalid value, keeping the value that was there previously. A different possibility would be the use of exception handling, which we'll cover in a later lesson. Let's skip over the plus plus operators for a moment. We'll come back to those. So here's our plus equals operator, which takes as its argument the number of days to add, and we just loop through that number of days and call help increment, which adds 1 to the date each time. And then we return the object that was being incremented by whatever number of days, and that allows us to use that in a concatenated assignment statement. Many programmers will simply return void from a function like this to prevent the use of that operator in a concatenated assignment, which also helps prevent some kind of strange operations from happening in certain scenarios. By the fact that we return a constant date reference from this, whatever gets returned from this function is treated as a constant and therefore can only be viewed, not modified. The leap year function takes the test year as its argument, and it checks to see if the year is divisible by 400 or if the year is not divisible by 100 and is divisible by 4. If either of those cases is true, then we return true, otherwise we return false. End of month, of course, checks to see if the current day is at the end of a given month. So if the month is February and it's a leap year, we can determine that the end of the month day is 29. Otherwise, we know that we can not know that it's 29. We can test the day to see if it's 29, in which case we know it's the end of the month in a leap year. And then separately, for any other value, we take the test day and check to see if it's equal to the number of days in the current month. And then finally, our help increment member function, which says if it's not the end of the month for the current day, just add 1 to the day value. Otherwise, if the month is less than 12, add 1 to the month value and set the day to 1, because I now know it's the end of the month and it's not the end of the year. And for the last case is the end of the year, add 1 to the year, set the month and day to 1. Now, let's go back up to our operator plus plus functions, and you'll see we have two different versions. They both are called operator plus plus, and you know that if you have multiple functions with the same name, that their signatures have to differ. Now, the strange thing here is that we have unary member function operators, and such functions are normally defined with empty parameter lists. But if we were to do that for both versions of the plus plus operator, then we wouldn't know how to distinguish between them because their signatures would not differ. So in C++, in order to overload the post-increment operator, you have to put this dummy integer parameter here, which is not actually used by you in any way. It's basically a note to the compiler that just says this is the post-increment version of the plus plus operator. So in the pre-increment version, we know that we want to increment the value right away, and the result of the expression should be the new value. So we call help increment to add 1. Then we return star this, which is the date object with its new value. In the postfix version, we take a copy of the current date object. We call help increment on the current object, and we return the copy of the original object. So at this point, before we return the copy, the original date object has already been incremented, but this date object it contains the original value, so we're returning the original value before the increment occurred. And by the way, look at line 40, because that is not the assignment operator there. This is actually a copy constructor call that could have been written as follows. We could have simply said date temp with a set of parentheses after it and star this, which is also going to make a copy of the current object. And basically, if you see an assignment operator, an equal sign, in a declaration, which means there's a data type as part of the variable declaration, it is not the assignment operator. In this case, it is actually another way of calling the constructor. When you have a constructor that receives only one argument, which is what happens with the copy constructor, you can use an equal sign in the declaration, or you can place the argument in parentheses following the variable name. Now you may say, well, wait a second, there is no copy constructor in this class. There's only a constructor that takes 3 integers. Remember, in C++, every class has a copy constructor. If you don't provide one, the compiler provides one for you. So there is actually a copy constructor here in this example. So again, there's two issues with the plus plus operator. The pre-increment version takes no parameters. The post-increment version, you must specify int in order for the compiler to distinguish the signatures, and then it will know which one to use in each case. In the pre-increment version, we return a reference to a date object because the date has already been incremented, so it's the object is ready to be used in a continuing statement to do whatever you want, so we return a reference to that date object. In the post-increment version, we get a copy of the original object, increment the original object, return the copy by value, and the reason we're returning the copy by value is because we're not returning the original date object. We're returning a copy that contains the old value, so we don't want any other operations that get performed on that date object we don't want the user to think that any other operations performed on that date object will actually affect the original date object in memory. Right, so finally, we have also a overloaded output operator with a static local array of C-style strings that represent the names of the month, and for each output of a date, we output the month name for that month, followed by a space, the day value, a comma, space, and the year value in this example.